Hello friends, my name is Salman and you are watching my channel Solid Tech. Now in this time I am starting a new series related to CCNA. Basically CCNA is a very fundamental training for network administrator or guys who dealing with the network. Basically this certification is very useful if you are starting your career in a networking. So this is very beneficial for those who want to know the basics of networking. In this series I will discuss the concept from fundamental to the advanced level. So in this video I will show you the operation of switch in regards to CCNA. So I will show you how the switches work and what is switching, what is the fundamental of Ethernet. So let's begin. So in this video I will show you examining the Ethernet cables, what are the collision domain is, dissect the content of Ethernet frame header, look at the operation of Ethernet switch, configure a Cisco 2960 switch. So I will discuss all these things in detail in upcoming slides. So you will have in-depth understanding of Ethernet. So the first model for networking is called OSI model. Basically OSI model is related to the communication, how the communication is related. So we divide the communication model into 7 layers or 7 segments. The lowest segment is called the physical layer. What is physical layers? Physical layer is the starting layer of the networking from the bottom. If I move from top to bottom, the topmost layer is called application layer and the last one is called physical layer. So you can say physical layer is the layer where all the components are joined together, for example cables, connectors. So this is called physical layer. In this layer we deal with the network interface layer component like wire, fiber optics and wireless. So the first thing is the wire. So we have a twisted pair wire, as you can see in our offices and our data center we have a twisted pair wires. Basically what twisted pair wires is composed of, basically it has 4 pair of wires which twisted each other to carry out the signals. Why we twist the wires together? Because when the electricity is passed through the wire, it will introduce a magnetic field which interfere our data when is passing through the wire. So to overcome this problem we twist the wire so it will cancel out the electromagnetic induction in the wire. So this is the picture of the wire. As you can see we have combined wire or we have splitting wire. So basically twisted wire have 5 categories, more than 5 categories, but these are the basic categories. For example, Cat 1, Cat 2, Cat 3, Cat 4, Cat 5 and Cat 5e. Cat 1 was used in earliest days when it was used only in doorbells. And it is obsolete now. The second one is token ring. Token ring also is obsolete now and it was used in early days. Now Cat 3 is still used in very few occasions. In Cat 3 we are using the Cat 3 in our telephoning system to connect our telephone. Or basically after that the Cat 4 is token ring, which is the IBM technology, which is obsolete now. These 4 ones are obsolete. They are no longer used in our communication. Now the 5th one is Cat 5, which is about 100 Mbps Ethernet. It is used, but it is also, I think it is also obsolete because nowadays I am not using or nobody using the Cat 5 Ethernet. After that we have Cat 5e Gigabit Ethernet. This is still using in the networking or data communication. So basically twisted pair are also 2 types. One is called unshielded twisted pair and other one is called shielded twisted pair. What is the difference between these two twisted pair cables? Basically when we have a large interference, for example if we are making wires or lay down our wire in a situation or in a place where a high voltage is also going with our wires, like in factories or in hospitals where the power supplies also run with our data cable. In this case, the induction or the interference on our data is very increases. So to overcome this problem, we are using the shielded twisted pair cable. As you can see, the twisted shielding pair cable have a extra coating of foil on the wire. So in this way, they minimize the effect of high voltages and high electric magnetic induction on the data, on our data. Also, you can see we have a Cat6 Ethernet cable. In Cat6 Ethernet cable, we have the same speed of gigabit Ethernet, but as you can see now we have a plastic sheet in between on the twisted wire. Basically, what this sheet what doing? Basically, it also decrease the interference of our data and also provide the strength on our wire. So nowadays, Cat6 is easily available and most of the use of for cabling. Now these are the connector which is found on the each end of the cable, Ethernet cable. So as you can see, this connector is called RJ45. We can plug this connector in our PCs, in our home network, or we can also plug this connector in our laptops. So basically, the connector have a 8 pins on it, and each pin have a specific configuration. We can cut down our cable, Cat6 cable, and insert into our connector with a special sequence. This special sequence or standard is called EIA-TIA-568B. Basically, this is the standard which always follows in our network. Otherwise, we have some problems for communication. So, what does this standard tell us? It tells us that the first two pins of our RJ45 connector is used for transmitting data, and the pin number 3 and pin number 6 is used to receive the data from any device. So this is the color combination for making any connector. So you can easily make connector by like this. So in the connector, what are the colors we have to choose on pin 1 to pin 8. So on pin 1 we always use white of orange, and then after orange wire is inserted, and after that white of green, and then blue and white of blue, and then green and white of brown, and finally brown. Basically this is used our network technician whenever they create any RJ45 connector. This standard is called EIA-TIA 568-B. So in this way you can see now in graphical way, pictorial way, I will show you the first one is white of brown and white of orange, and then second one is orange, then white of green, then blue, and then white of blue, then green, and white of brown, and finally brown. This is our connection. We can use remaining pin for some other purpose. I will discuss in my future video when we discuss about PoE. PoE basically power over Ethernet. So we can use the other remaining pin for power of Ethernet functionality. So there are two types of cable, which is the one is called straight cable and the other one is called the crossover cable. In crossover cable, we sweep the function of the connector on both the sides. For example, in one side, the pin which is used for sending is become the pin which is receiving, and vice versa. Basically, this is the crossover cable. So as you can see now, 1 and 2 is joined to the 3 and 6, and 1 and 2 for the other side is joined to the 3 and 6. So this is the pictorial representation of the cable type. So as you can see, we have a left side, the pair is represented the straight cable, and the right side we have the crossover cable. So basically, why we make crossover cable, why we use crossover cable? Basically, when we connected same devices like two switches or two computers, we always use the same crossover cable without the use of switch or hub. But as you can see, when we connect the two routers, when we connect the two switches, and when we connect the two PCs, we always use the crossover cable. So you can say when we connect the same like devices like PC, switch, router, we always use the crossover cable. But nowadays it is not mandatory to use the crossover cable, because the now is very advanced technologies. So it will auto sense what devices are on the both end. So you can also use a straight cable in place of crossover cable. So as you can see, I am explaining the where we use the crossover cable and where we use the straight cable. So as you can see, straight through cable used to connect to our PC to our switch, and straight through cable also used to connect a cable through a switch to a router. So now the second type of cabling is called fiber optics. This is the very important topic, because the fiber optics is now used in modern networking. The first question arises, why we use fiber optics? What is the need of fiber optic? So the answer is very simple. If you want to move your data more than 100 meter, then you cannot use the copper cable or Ethernet cable, as we discussed earlier in our previous slides. So if our distance is more than 100 meter or 200 meter or 100 kilometer or 10 kilometer, we always use fiber cables, because the fiber cable is able to take the signal from more distances than the copper cable. So this is the fiber cable. As you can see, I have a 3 picture on my top. The first two is the first two fiber optics color is yellow. What is yellow color? Donate us or mention us. It means that yellow color means the fiber optics is a single mode fiber. What is single mode and what is multi mode, I will discuss in later on in these slides. So whenever you see a yellow color fiber, you always call it a single mode fiber. Single mode fiber is more reliable and take the signal more distance than the multi mode fiber. So this is used, single mode fiber is used to when you have a two distance building on very large distance, for example 10 kilometers, 50 kilometers, 20 kilometers. In this case we use the single mode fiber. Now other the hand you can see we have a orange cable. The orange cable is called, whenever you see a color of orange on any fiber optic cable, you can call it a multi-mode fiber. Where we use multi-mode fiber? Multi-mode fiber is used within a short distance of time. For example, you can use in your data center, as I am using multi-mode fiber to connect my SAN to my chassis or my servers. For connecting the fiber to the switches or any other devices, we use an hardware which is called SFP. As you can see in right bottom side, we have an SFP. We can plug this connector of our fiber optics cable into this, insert into the USB, and this USB insert into our switch or routers or whatever device we have for communication. So this is the fiber optics. So as you can see, I have two types of fiber, single mode fiber and multi mode fiber. Single mode fiber is having a very small cylindrical type core in which the light is travel for very long distance. In multi-fold fiber, the cylinder is very wide and the light is travel very relatively very small distance. So this is the pictorial representation of the two types of fiber. So for example, let take some example how we connect two buildings together with the help of fiber. So now we have two buildings, we have two switches on each building, and the distance between the switches is more than 100 meters. So how to connect this switch? So we have a two building, one is called west side and other is called east side office. So in west side office we have two switches, and if we want to connect these switches with the help of fiber optics, how we connect this fiber with the single mode fiber or multi mode? Because the distance is very low, but it is more than 100 meter, so we used to connect this fiber with the multi-mode fiber. So as you can see, the color is telling us which type of fiber it is. It is orange color, that means it is a multi-mode fiber. Also the distance is very short as compared to the building to building distance. So this is called we used multi-mode fiber to connect the switches within the building. Now if we want to connect the building together, each other, so what type of fiber we are using? In this case the distance is more than let's suppose 10 kilometers. So in this case we will connect the building with the help of single mode fiber. As you can see, the color is tell us what type of fiber is it is. So the yellow color always tell us that the fiber is single mode. So now we are taking a look at what type of laser in use in multi-mode fiber and single mode fiber. So laser type in single mode fiber is called LX, and the wavelength of this fiber is 1217 to 1355 nanometer, and it is called single mode fiber. And the most important thing is it is used to cover the distance up to 70 kilometer. If you have a distance let's suppose greater than 1 kilometer and less than 70 kilometer, you always use single mode fiber. On the other hand, if your distance is less than a kilometer, for example half to 1 kilometer, you always use multi-mode fiber. We denote the single mode fiber with the letter LX, and with multi-mode we use the letter SX. So now as we see the in case of copper cable, we see the connector type is RJ45. Now in case of our if we using a cable of fiber, we have some other connectors which is very popular in nowadays. The first connector is called ST connector. Basically this connector is used single core fibers, and this is round connector, and this is typically used when we connect a very large distances. So this is called ST connector. It is round in shape. The middle one is called SC connector. SC means square connector. It is also used with the single mode fiber, and it is very common to use with ODF. I am using in my data center to connect my ODF to the external ODF with the help of SC connector. So this is very commonly used connector. Now the third one is called LC connector. LC is very small in size. It is also square, but its size is very small, and it is easily pluggable in our USB. So I am using this connector within my data center. For example, I connect my switches with the other switches with the help of LC connector. I use to connect my SAN storage area network with my servers with the help of LC connector. So these are the most important types of connector used in fiber optics. So now I am talking about the first layer. What are the cable type and what are the connected type used on a first layer of the OSI model or our networking. The second layer is called data link technologies or data link layer. Basically after in OSI model, the after bottom layer, the above layer is called data link technologies. So what is the function of data link technologies? For example, if you have a buddy in the other section and in other country or other city, you want to send some gift from your side to other side, what will you do? You send your gift with some carrier to drop your gift from your city to another cities. So same like we have with the help we have an option in our networking. We have a copper wires or fiber optic wire which carry our data from one place to another. So for this purpose we have a model which is called Ethernet model. Basically, what is Ethernet model? Ethernet model is the very important model. What it does, it describes us how to connect the two devices, how to carry the data from one device to another device with the help of switches and hub and wire. All, if we combine all together, this communication we called Ethernet, and it is developed by IEEE, and its standard is called 802.3. So in Ethernet cable, in earlier Ethernet cable we are using some configuration like 10 base 5, 10 base 2, and nowadays I am using a 10 base T. T represents the twisted pair and 10 represents the speed of the data speed in megabit per second. For example, we were using 10 base T in our in previous days, and after that we are using 10 base 100 bands T, which is also obsolete nowadays. Now we are using a 1000 base T, which is a gigabit cable. So now after the medium like copper and fiber optic, now the communication moves to the wireless. So if you want to if in your home and in your office you have a Wi-Fi. So in Wi-Fi we are using the medium of air as a air. So how to use Wi-Fi and what are the standards of Wi-Fi, why we and what was the speed of the Wi-Fi standards. So basically Wi-Fi, if we talk about the data communication in terms of wireless medium, we call this 802.11. 802.11 also is always represent the communication taking place on a wireless medium. So in 1997 the first version is coming is 802.11. After that we enhance this version and we call it 802.11a, 802.11b and 802.11g and on the green side what it does, what is represent on the green side, the spectrum of the wireless network is using the frequency range of 5 gigahertz, and on the bottom on the blue side we are using the ranges of our wireless in 2.4 gigahertz. Basically these are the two spectrum, those two channel which are using for the communication of over a wireless network. And nowadays I am using a standard of 802.11 AC. AC uses very advanced protocol and uses the speed of up to 1 gigahertz. So now we take the look one by one what are these standard tell us. So 802.11a uses the 5 gigahertz spectrum only. It is operate only in 5 gigahertz. Its bandwidth is up to 4 megabit per second bandwidth. Initially used for enterprise use because it is very expensive. That's why it's used in enterprises only. Now on the other hand, 802.11g uses 2.4 gigahertz spectrum only, and its bandwidth is up to 54 megabit per second. After that we have a G, 802.11g, which is used 2.4 spectrum only, up to 54 by Mbps bandwidth, and it is used in enterprise and SOHO. SOHO means small office and home office. In these places you can use 802.11g. These are the obsolete technologies. These are no more used in any environment. I never seen in nowadays it is using. Now after that we have a 802.11, and this technology is still using in some places, but it is also obsolete. It uses both the bands 2.4 and 5 gigahertz spectrum. It has a speed up to 300 megabit per second. But it also uses a technology which is called MIMO. MIMO. What does MIMO mean? MIMO means multiple input and multiple output. Basically, MIMO is what MIMO does. MIMO have a multiple antennas on our routers. As you can see, we have modern routers which have 4 antennas or 8 antennas, to which using the other different channel at the same time. So now the final Wi-Fi standard is called 802.11.AC. AC uses only the 5 gigahertz spectrum, and the speed of AC transmission is 1.3 Gbps. It is used MIMO and along with the beamforming. Beamforming is also a new technology which separate the MIMO channel from to each other. It minimizes the interference. So this is the latest technology which is used all the enterprises nowadays. So now we have a serial communication protocols. We have some serial communication protocol. Basically, serial communication protocols, what it does the communication between your telco to your home. For example, in old days we use the dial-up modem, which is used telephone line. So in this communication we were used to protocol like point-to-point protocol, high in Cisco we call it high level SDLC and frame layer. These are the obsolete protocol, but you know what was the protocol in old networking when we are using the dial-up modem, or when we using the copper cable, to one pair of copper cable to making a connection with the help of telecommunication system. So these are the protocol used in old technology. Now I will take the Ethernet operation, a brief history, when Ethernet is formed, how it will change, what are the body governing in a Ethernet. So basically Ethernet is formed in 1973 by Bob Metcalf. This is called the first Ethernet, but it is not a true Ethernet. The true Ethernet was formed in 1982 by the three companies which is called DAG, Xerox and Intel. Basically they made a consortium which designed a system of Ethernet, and it is called Ethernet 2, and it is formed in 1982, and we call it as 802.3 by the under the supervision of IEEE. IEEE is an organization which set the standard of communications. So we can say the Ethernet is formed, the true Ethernet is formed 1982, and we call this Ethernet 802.3. Basically Ethernet describe us how to we connect a device in our LAN, and how to, for example, how to we connect the cable, connectors, switches, and with our PCs, routers. So Ethernet is very important. So after creating the Ethernet, we enhance the Ethernet, and for basically what we enhance in the Ethernet, we increase the communication speed, which is called bandwidth. In 1995 we have 100 Mbps, and in 2000 we have 1 Gbps of bandwidth or speed of our data transmission, and in 2002 we have a 10 gig Ethernet, and in 2010 we have 40 gig Ethernet. Nowadays we are using, in 2011 we have designed, IEEE designed the Ethernet which support speed up to 100 Gbps. Basically 100 Gbps using when we connect the two cities together, and basically it is used for backbone of any network. So in real life I seen we are using the speed up to 40 gig Ethernet in our data centers. I am not seen anywhere where we are using 100 gigabit per second speed in my life, but it is used by telcos company to connect our two cities or two countries together. So this is all about the first lecture of CCNA. If you like this video, so please hit the like button of your in my video. So I will make any video like this in the future. Thank you very much for your time.